This is problem number 8 from section 3.2. In this problem, they say a box with no top is to be constructed from a piece of cardboard whose length measures 8 inches more than its width. So I want you to keep in mind here, we're making a box, but the cardboard is flat right now. So that's what this picture is demonstrating here. The box is formed by cutting squares that measure 3 inches on each side from the 4 corners and then folding up the sides. All right, most of you have probably done this before, or at least seen it done, whether they were boxes that clothes came in or whatever. This is a flat piece of cardboard. They're cutting in the corners of that cardboard, and then they're folding the sides up. And so the sides fold up and they meet, and you'll actually end up with a height of the box of 3 because you cut it in 3 inches. It says, if the volume of the box will be 384 inches cubed, what are the dimensions of the piece of cardboard? And they want the original dimensions of the piece of cardboard. So the volume after, volume is 3-dimensional. So after you fold it up, the volume of that box is 384. They tell us some important pieces of information. They tell us that the width of the original piece of cardboard and the length is 8 inches longer than the width. That's important for us to use here. But then they tell us that they do some cutting out of the edges. So that changes immediately the width and the length of the box. So let's start. First of all, we know when you cut in 3 inches, we know the height of this box is now going to be 3 inches. The width of this box started as W, but we cut 3 inches here and 3 inches here, so now it's the width minus 6 inches. So we can call this, and this is kind of weird to say, but we're going to represent the width as W minus 6. And the length then, it was already W plus 8, right? Whatever the width is, plus 8 inches extra. But we're cutting 3 inches out this direction, right? This is minus 3 and minus 3. So we're going to have W plus 8 minus 6, right? Because 3 on each side, which is really just W plus 2. So once you make the cuts, the height of the box is 3 inches. The width is actually what the original width was minus 6 inches. And the length is actually what the original width was, not plus 8 now. It's plus 2 because you cut 3 inches off of each corner. That's really the hard part of the problem. After this, we know volume is length times width times height. So we just set up our equation that way. Let's start by saying height of 3, or we can start with the length. We'll start with the length. W plus 2 times the width, which is W minus 6, times the height, which is 3, equals 384. And I'd write inches cubed, but you know it's inches cubed. It'll just save us a little time as we go through this. So then let's distribute here. So we end up with W squared minus 6W when we do the W times negative 6, plus 2W minus 12. And I'm actually going to put the 3 out front. I like 3 out front. Doesn't matter where it is. I just pet peeve to put the 3 in the front because we're going to distribute it anyways, right? Equals 384. So now we have 3, and we're going to get W squared minus 4W minus 12 equals 384. A couple more steps here. Distribute the 3. We get 3W squared minus 12W minus 36 equals 384. Subtract the 384 over here so we can set this quadratic equal to 0. This is a quadratic equation if you haven't noticed here, right? Quadratic equation, we're going to have to solve that. Subtract the 384 over, that's 3W squared minus 12W is see that, plug that in, that's minus 420 equal 0. Let's use the quadratic equation or quadratic formula to solve this. So we start with negative b, which is negative 12. And this is x equals, but we have w here, so we're actually finding the original width here. Right? W equals negative 12 plus and minus root negative 12 squared minus 4 times a, which is 3, times negative 420. And that's all going to be divided by 2 times a, which is 3. Let's start to evaluate this. We can throw in negative 12 squared, so 12 squared. Actually, I'm just going to put it in exactly how it is. So negative 12 squared minus 4 times 3 times negative 420. 5184. So we end up with 12 plus and minus root 5184 over 6. We'll do the square root of this, 72. So we get 12 plus and minus 72 over 6. And that's going to equal 12 plus 72 over 6, or 12 minus 72 over 6. Now, one of these you can look at right away and determine that it's not possible. And that one is the 12 minus 72 over 6, because we're finding the width. This will give you 12 minus 72, which is a negative. We can't have a negative width, so this is not actually going to work there. So we're going to say that W equals 12 plus 72 divided by 6. So our width here is 14 inches. So the original width of this thing is 14 inches. How do we find the actual length then? Well, we know the length, all right, the length of this. Now remember, this length, okay, is the length after you subtracted 6 inches from the side. We're not looking for the length after we subtract the 6 inches from each side because we cut the edges. We're looking for the original length of the box, or sorry, not of the box, of the cardboard. And that was W plus 8. So we come back and we say, all right, length is W plus 8, which we know is 14 plus 8. So that is 22 inches. So the width of the original cardboard, so this is original cardboard. Their length and width of the original cardboard is 14 inches and 22 inches. After you cut the edges, right, the width then would be minus 6, so that's 8 inches of width. The length would be, it looks like to me, the length would be the width plus 2, so the width here would be, it'd be 16 for the length. And you can see that by subtracting 6 from this, right, because you cut out 6. You'd have 16. So after you do some cutting, right, the widths and the lengths change, but these are the original ones.